Hi, my name is Gabriel. I've been studying the Bulkhead pattern for a while, and an important thing that I wanted to know or to understand is when to use a Semaphore Bulkhead and when to use a ThreadPool Bulkhead. I know how a semaphore works and how the ThreadPool patterns in general terms works. So the simpler and more obvious answer to this question could have been, shall use a semaphore bulkhead when you want to limit the number of synchronous calls, and use a ThreadPool bulkhead if you want to limit the number of asynchronous calls. However, there was an idea that was around my head, and the idea was Spring already offered us the async annotation that allow us to send asynchronous requests. So why not just use this annotation together with the bulkhead semaphore annotation, a semaphore bulkhead annotation? Can these both annotations work together? And if the answer is yes, why we need a ThreadPool bulkhead implementation? So I built some test cases that help me to answer these questions. The first four one are just to organize the ideas, and the more interesting ones and the last two. So I'm going to execute the test cases and to make some conclusions. So let's execute the first test case. It's the simplest one. We have a client that makes a request to a service, and this service, in order to complete the work, needs to call another service. The second request is isolated using a semaphore bulkhead. Let's see the semaphore. It's a very simple method that uses this bulkhead configuration that say that the bulkhead allows a maximum of 4 concurrent requests. Let's see the client. Here is our client. It generates 6 concurrent requests. So let's execute it. We need to wait because are synchronous requests. And let's check the result. As expected, 4 requests were accepted and 2 requests were rejected because the bulkhead was full processing these 4 requests. Test case 2 is very similar to the previous one. The only difference is that service 1 calls service 2 using an asynchronous call, and service 1 doesn't wait for the service 2 respond. It immediately sends back a response to the client. It's like service 1 just wants to trigger some event on service 2. Let's see the code for a moment. Here is the method that invokes service 2, and the important thing is that we are isolating the call using a ThreadPool bulkhead. Case 2 is the configuration, and it says that the queue capacity is 2, and it allows a maximum of 4 threads. Let's execute the test. We don't need to wait for the server response, and from the client's perspective, the 8 requests were success. Let me show you that this test case generates 8 concurrent requests. However, in the server side, we can see that 4 requests were processed immediately, and 2 requests were put in the queue and were processed later, and 2 requests were rejected because the thread were busy, the queue was full. So this is a very common behavior of the ThreadPool bulkhead. Test 3 is very similar to test 2. The only difference is that it uses
another ThreadPool Bulkhead, that test case 3, that is configured with a queue capacity of 0 instead of a queue capacity of 2. And if we see the Resilient for Java source code, we can see that when the queue capacity is equal to 0, it instantiates a synchronous queue instead of an array blocking queue. And this has a little impact on the behavior of the bulkhead. So let's execute the test. Again, we don't need to wait for the server response. From the client point of view, the A requests were success. And for the server side point of view, we can say also that the A requests were success. The first 4 requests were executed immediately, and the remaining 4 were executed about 3 seconds later. This is an epoch time expressed in seconds. And the reason of this behavior is when the threads in the pool were busy processing the first 4 requests, the synchronous queue blocked each client thread that intend to put a task in the queue. And the threads were blocked until new threads were available from the thread pool. So let me execute this again. Let's go to a test, and let's execute the test again. So here it's very clear the behavior of this kind of bulkheads. When the threads are busy, the rest of the client requests remain blocked. I think this is the expected behavior when you use a synchronous queue.
The following test implements an orchestrator pattern. The idea is that service 1 calls service 2 and service 3 using asynchronous call. Each call is isolated using a bulkhead service 2 and bulkhead service 3. It needs to wait for each response, and after that analyze both of them and send back the response to the client. I think this is a very common scenario, or at least a more common scenario than the one that we saw before. So let's execute. First of all, let me show you this in a special implementation of this test. The idea here is that when the method that calls service 3, we are using the async annotation provided by Spring to generate the asynchronous call, and we are using a Semaphore Bulkhead. So we are not using a ThreadPool Bulkhead to generate an asynchronous call. We're using the Spring annotation and the Resilient for Java annotation working together. The same thing to the method that call service 4. And if we see the configuration of the bulkhead, service 3 and service 4, it will allow a maximum of 2 concurrent calls. So let's see the test. Let's send just 1 request. Let's see the server console is clear. Let's execute the test. We need to wait for the response, about 5 seconds, and from the client perspective, the request was okay. Let's execute again and show the server log.
Here we are waiting for the synchronous call, and when the response arrives to the orchestrator, it analyzes both of them and sends back the response to the client. Let's see the client again. We have 2 success requests. Let's increment. So now we can see that the asynchronous annotation is working, and let's now increment the number of concurrent requests, concurrent clients, and see if the Bulkhead, the Semaphore Bulkhead, works well. Let's start the test. And we can see that 2 requests were rejected and 1 request was success. In the server side, we can see that 2 requests were rejected because of the Bulkhead was full. And remember that the Bulkhead configuration said that it allows a maximum of 2 concurrent calls. So we can say that the both annotation work together. However, this approach has a problem. According to the Spring documentation, Spring offers different implementation of the task executor interface, and by default, when you use the async method, Spring uses the SimpleAsyncTaskExecutor. This implementation does not reuse any thread, rather it starts up a new thread for each invocation. So according to my understanding, when this is the diagram that shows how the async annotation work with the Bulkhead annotation. So this is the client thread that want to execute an async annotated method. So Spring create a new thread, and new thread asks for permission to the Bulkhead, and if the counter, the semaphore counter is greater than 0, the thread is allowed to execute the method. However, if the Bulkhead is full, this new thread is not going to do any work. So clearly we are wasting resources because we are creating a lot of unnecessary threads. So let's see this use in the real example. So let's start the profiling tool, and let me show you the test that we are going to execute. In this case, we are going to generate a constant number of threads, 4 threads per second during 60 seconds, and we are going to invoke the same method that we invoked in the previous test. So let's come back to the profiling tool, and let's monitor the number of threads that the application create, and let's start the test. Okay, the test is executing. Let's see the server side. The server is working, and let's see the profiling tool. Here, what I want to show is that the number of created threads, this number is increasing a lot, and the application is just using about 30 threads. However, it's creating a lot of threads. This, as I said before, these threads are created and immediately, almost immediately, are destroyed. So clearly, we have a wasting resources situation here, because we are creating a lot of threads, and this is not free for our system. So after 1 minute, the application has created more than 500 threads. We can improve the previous situation and say to Spring that use a ThreadPool instead of a SimpleAsyncTaskExecutor. So let's comment this configuration. Let's uncomment this one. Let's start the server. And let's start the profiling tool again. The server is deploying. And let's start the test. The test is running. The server is running. And let's see the number of creator threads. As we can see here, the number of creator threads is not increasing. We have created 41 threads. The application has created 41 threads and is using 35. So I think this number is much better than the numbers that we saw in the previous test. I think that we are not wasting resources here, but the problem with this approach, I think, is that we are using a thread pool because we are using the async annotation, and Spring provide us the thread pool, and we are also using a semaphore because we are using the Semaphore Bulkhead implementation of Resilient for Java. And I think it's not quite necessary or suitable to use these two controls together. I think we have a redundancy here, and this redundancy is not add any kind of value to our solution. So in conclusion, the conclusion that I made is that just for control the number of asynchronous call, just use the ThreadPool Bulkhead annotation provided for Resilient for Java, and it's not necessary to, and it's a better solution that use an async annotation together with the Semaphore Bulkhead. So that's all. Thank you.